Today we were supposed to start studying collections, but we still need to know a couple of things to do that. Today we'll study that couple of things, and then we'll get to collections. First will be the keyword import. You already dealt with that when we were studying packages, so every time when we want to use some code which is not in our package, and the code which was written by some other programmers, we must import the class we intended to use. Let's take a look at one example. When we study collections, we will be using such a class as ArrayList. Let's open our method main and remove all the code from here. Write the name of the class, ArrayList. Type it in fully by yourself. Do not use autofill function. ArrayList. You can see an error. We cannot use this class because it's located in a different package, and we haven't imported that. The class is in package java.util.ArrayList. Let's write this. Import java.util.ArrayList semicolon. You can see that the error is gone. It often happens so, especially at first, that we know the name of the class we want to use, but we don't know the name of the package. Fortunately, IDEA suggests us to do it. Let's delete the line with import. The error is back. Now hover over your mouse on this error, press Alt-Enter, and select Import Class menu item. It gets imported automatically. The same can be done using the autofill function. Let's delete it. Write ArrayList, and when the required option pops up, press Tab. And again, the class gets imported automatically. You might ask, why when we were using class math, we did not have to import anything? Let's find it out. Write math and see what package it is in. java.lang. Now delete math and let's write string and see where it is. java.lang 2. Below you can see string buffer, which is also located in java.lang. String builder is also from java.lang. And there are many more classes located in java.lang. Since this package is so often used, the developers decided that it will be imported automatically. It was done not to write import.java.lang in every program. So that's all about import. Something of what I told you now was just a revision. Now here's another small topic. Type wrappers. Sometimes we must use types primitive, int, long, boolean, and others, like reference ones, as if they were real objects. Today you will see an example of when it can be required. So every primitive type has its own reference analog with almost the same name, but with the first capital letter, like all class names. Let's create an integer variable int a equals 5. Primitive type int is short for integer, so the reference type will be called integer. It can be used just like the primitive 1. In fact, when we assign value 5 to the reference variable integer, it's a primitive variable which is created, and later it's converted into an object of integer type. This is called auto-boxing. You don't have to go very deep into all these details. You must understand one thing. Using reference types instead of primitive ones is an extra step for a program to take, and thus extra resources will be required for that. It means that you must try to use primitive types where possible, and only when there is no other option, you will use wrappers. When we use a reference type instead of primitive type, it's called type wrapper. Let's create variables of all primitive types and then their wrappers for you to know the syntax. The first type is byte. Its analog is spelled byte too, but starts with the capital letter. Then there is short, and its analog short with the capital S. We have seen int, then there is long, and its analog long with a capital L. Then char and its reference analog will be spelled fully character. There are two types with a floating point, float and double. The last one is Boolean. Its reference analog is Boolean with a capital B. Actually, all variables except int and char have the same names which begin with the capital letter, and char and int types, which are short for integer and character, are written in their full form. Let's take a look at one example when we have to use wrappers. Delete this, create a string in which we'll pass the value of 1000. Do not forget that although the string equals 1000, it's still a string, so operations of addition or subtraction are not applicable to it. We can make sure it's so. Let's create another string and assign it the value of 2000. Let's print s plus test. If it were int type, we would have 3000 in the output. But these are strings, so 1000 and 2000 are printed out. In other words, the strings have been concatenated with each other. And what if we want to get a number out of a string? There is a static method just for that in class integer. Let's create an int variable. It doesn't matter what we'll call it. Assign it value integer. Now call static method parseInt. A string containing a number is accepted by this method as a parameter. Let's parse our second string. And now let's print out their sum. Run the program. Now 3000 is printed out. The same method exists for all type wrappers except character. It means that we can parse a string to byte, short, int, and even boolean. Let's delete it. Write string and assign it value false. Now let's create a boolean variable and assign it value boolean.parseBoolean. Let's pass the string. Now we can print out the value of variable b. Run the program and see false. Of course, if this is written incorrectly, for example, if a string not containing a number or containing not just a number is attempted to be parsed, the program will terminate with an error. The only difference is the Boolean type. When it's parsed, it converts true into true. It converts and everything else into false. Now let's discuss one more thing. It has nothing to do with collections, but you have an exciting homework assignment, you will need to know this. Let alone it's very often needed in life. There is a string. It's Igor. He's a programmer. We want to retrieve the name from the string and save the name in a separate variable. Let's create this variable. String, name, assign symbol. All the strings have a method for that, and it's called Substring. Write the variable, in this case it's s dot, and here it is, our method Substring. It has two overloads. The first one accepts one parameter, the begin index. The second one accepts the begin and the end indices. Let's call the method and see what it does. It cuts the string from the index we'll specify. In this case, we want to retrieve variable Igor. Let's see what is its index. I has index 0, then 1, 2, 3, and 4. Letter I has index 4. Let's specify 4 and print out the value of variable name. We get Igor, he is a programmer. It's not what we need. But we can now see what this method does. If you specify only one parameter, it returns the string from the given index up to the end. Let's specify the end index too. The last letter will have index 8, so we should write comma and 8. Run the program. We have Igor in the output. It seems like the last index is not included in the string. So to have the name without contractions, we'll specify one index more. Write 9 and run the program. Well done! We have Igor displayed. And now the homework assignment. You must create object main with the following fields: string name, string position, int age, and double height. All fields must be private. Then create a constructor to initialize all the fields. In the class main, you will have the string. It's Ivan, he's 34 years old. He's 166.3 centimeters. His position, programmer. You must parse the string, or in other words, you must retrieve data from it. Save all the required data in separate variables, and then create a new method main. Pass the data retrieved from the string as arguments to the constructor. And finally, print out the values of all the variables. Remember that the variables are private. It means that in order to print them out, you'll need getters. Good luck!